So what we're going to do today is we're going to talk a little bit, both myself, Eric, and Brett, both work in the DCSG division in Broadcom. I'm responsible for NIC security. Brett does storage and PCIe switches, and we've both been involved with the OCP security group, and Brett is pretty active in TCG. So what we want to do is kind of give our perspective on how you take DICE, SPDM, and OCP Attestation, kind of combine them together and create something that hopefully works. Okay. All right, so a bunch of background. The first thing to think about is the original DICE the initial DICE specs were published a long time ago. They were very targeted towards IoT implementations. And a lot of the initial certificate formats and a lot of the way that they were doing some of the firmware measurements is definitely different than the 3 newer specs that have come out. And it's one of the things that, that's a kind of a pitfall for here. So if you look at TCG, there's the attestation architecture, which was published a little over a year ago, or actually 2 years ago now. There's a layering architecture, which is how you combine these together. And then there's a new spec that Brett is actually one of the authors of, which is this DICE SPDM binding spec. And what this spec does is figures out, okay, how do I take pieces of DICE and map it into SPDM? And there's another ballot publication, which is the endorsement specification. And the endorsement specification has the ways to actually specify up to the attester what the expected measurements would be and what your manifest is. So hopefully we can talk about these different things and kind of figure out at least a little pieces of how to do this. Okay, so I'll give a very brief overview of DICE just to provide some background. The big terminology is there's a UDS, it's a device unique secret. It is the kind of the crown jewels. It's where everything starts. And then if you look at the layering architecture, what they do is they build these compound measurement derivations up the stack. So a CDI is the measurement, is a combination of measurements and the UDS, and basically it's communication to the next layer of the unique identity. And what happens is that each one of these layers you generate or can generate a new set of certificates based on that. And the nice thing about this is it's all layered. So if any one of the intermediate layers changes, everything rekeys up and down the stack, and you get a very good, basically, path back to the original hardware implementation. One of the big issues, or the big pieces of this is layer 0, which is also called the first mutable code. It's the first thing that runs, it's not ROM, and that's part of the measurement, and that boots this entire thing up. Okay, so if you look at the motivation for TCG to do a binding spec, TCG is a lot of documentation. DICE is a really active work group. And I think there's been a pretty good, and also in DMTF, the SPDM has become a pretty much de facto standard for attestation communication. It's being used by PCIe. It's very actively being developed today. The 1.2 spec is what's out today. That has a roadmap to additional pieces. So what the TCG group and DMTF wanted to do is, okay, let's get together, write a white paper, a spec of how you glue this stuff together. The motivation, I think we talked about this, is there's a number of different artifacts. There's a bunch of things around how you actually implement this, and and this tries to specify that. The spec covers kind of 3 main areas. SPDM, like many of our specs, have a bunch of optional features. Which this does is tries to put together this is the set of requirements for SPDM. Fortunately, Brett and I also helped with the OCP Attestation spec. So these are well aligned. we did a pretty good job in kind of figuring out what this would be 2 or 3 years ago when this was done. So now if you look at from an SPDM perspective, the DICE says, okay, this is a set of requirements. Also, it goes through a set of certificates, how those certificates are chained together, and also has a bunch of metadata in the certificates in order to figure out how the measurements chain together and what the expected results are. Right now, what they're doing is they're using, there's another group within TCG, which is an evidence manifest, and I think this is called CORIM. There's also one of the best IETF groups ever, which is Eat Rats, which has some parts of this. But at the end of the day, what they're trying to do is come up with an evidence manifest that says, okay, when you challenge the device, you get all the measurements back, what was the expected results? This has always been one of the key things with attestation. It's like, well, that's great. How do I know that this is the right results? If I do repeated measurements, I can see stuff hasn't changed, but how do I know that this version of the firmware should have this signature? That's a really difficult problem, and this tries to address this. So now what I'll do is to hand it off to Brett, who is much more knowledgeable about this, to discuss some of the pieces.
All right, thanks, Eric. So yeah, so we're going to just hit a few of those highlights, really those 3 sections that Eric mentioned. We're just going to touch on all 3 of those sections. But first, just what are the pieces that we're bringing together? This binding spec really wasn't trying to go in new directions or create new artifacts. It was really trying to show how to take pieces of the ecosystem and pull them together. So this is a pretty common diagram. We stole this out of another TCG specification, and really just wanted to show the pieces that we're talking about in the binding spec. So we're touching on the endorsement, so that's the reference manifest. We're also touching on the evidence manifest and the certificates, so that's both your reference and the evidence that's presented. And then we touch on SPDM, which is how you move that evidence from a device to a verifier. So it's really these bubbles that we're tying together. So one of the places where you get evidence in an SPDM and a DICE implementation is from the certificates themselves. So the certificates will have, if you read through DICE, it tells you how to put measurements in the certificates, it tells you how to put identity information in there, and even device modes and the security version number and all kinds of details. They can go in the certificates, and by following DICE, you can protect the certificates against further unauthorized changes. SPDM has both a device cert model and an alias cert model. The history on SPDM is the alias cert model was really added in order to support putting DICE on SPDM. So that's one of the areas where the binding spec gets a little more prescriptive, is it does direct you towards the alias cert model because that was put in there to support DICE. And then just a note, so this is part of that. Lessons learned from implementing this that Eric was talking about. There has been some evolution in the DICE specifications over time. We definitely encourage people to read the latest versions of the specs because there are some inconsistencies if you go back to the very first documents that were published. So you definitely want to go to the latest stuff. Another part of the binding spec is trying to sort out terminology between the 2 groups. And the route that we chose was really to go a decoder ring route. We didn't think either group was going to fully morph all their terminology to match the other group. So instead, we decided to use the binding spec as kind of this piece of bridge material to just say, all right, here are the analogies between the 2 standards bodies. This is a diagram that's actually out of the binding spec. This shows how the certificate stacks line up against each other. And intentionally, it shows the different terminology that's used at the different layers. You can actually draw very easy analogies between these, so that's very handy. And we go through a bunch of other parts of the ecosystem and just show where the 2 standards bodies are. Let's see. So another thing. So this is one of the other chapters that's in there is how you deal with manifest. So manifests are an important part of the TCG ecosystem. TCG creates both reference manifest and evidence manifest. The difference is you can think of a reference manifest as the answer key. So this is something that's typically going to be produced by a manufacturer or a data center operator, and these are an endorsed set of measurements. So this is where you go to see whether or not you have good answers. There's also the concept of an evidence manifest. So you're going to get measurements off of a device. It's going to send you its SVN, its firmware version, its measurements of all the different layers. Right? You're going to pull this off the device. Well, you need to have a way to match that up with what you got in the reference manifest. Right? It's not good enough to just say, well, you know, one side said 1, 2, 3, 4, and the other side said 1, 2, 3, 4, and that's good enough. So instead, you need a data structure that actually shows you where these measurements came from and where they're supposed to line up. And that's what the manifest does. This manifest I'm showing, this is in JSON. When you read through the spec, you'll see that when it actually goes across the wire, it gets encoded in CBOR. So we do turn it into a binary format to make it much more concise to send across the bus. But JSON's a much easier way of reading through it. The manifest has a bunch of different header information. So it has very helpful things like a globally unique identifier and references to the entities that created it. Since this is TCG, there was a lot of thought that went into the entities. You can actually have more than one endorsing entity. So there are ways to layer endorsements if that fits your model. And then the other part of the manifest, is really the heart of it, are the triples. And so these can be reference triples or evidence triples. And these will contain some sort of identifier for the environment that took the measurement, and then various metadata about the provider, and then the reference measurement itself. And if you notice line 19 in here, this has reference values. This also, you actually end up with the exact same thing, except it says evidence if it comes from the device. And so when you have to go through and write a verifier, it's actually pretty easy to walk your way through these data structures and find out which which item in the reference is supposed to match up with which item that came out of the evidence. Delivery. This was one of the things that we had to figure out when doing the binding spec, was where were we going to actually insert this into the existing SPDM work. Our big goal was to keep it as simple as possible. Really, we didn't want to go upend SPDM just to add these types of things. So there was an existing measurement index that was set aside for delivery of a manifest. So what we specified in the binding spec was that's the index that you use to return the manifest. That's index FD. If you look at SPDM in detail, you'll actually see you're allowed to return either a raw bit stream, so the entire data structure of the evidence, or you can return a digest of it. So that actually allows a verifier to pull a new copy of the manifest or just monitor the manifest to see if something changed. We also have something that's specific to working with SPDM, and this is called the indirect method. And unfortunately, we didn't add the slides to go into all the detail on that. But the idea of the indirect method is SPDM already has a bunch of different measurements at different indexes, right? You might have index 1 through 30 containing different measurements. And so we wanted to provide an optimized route to just reuse those. And so one of the options in the binding spec is you can actually structure that manifest so that instead of containing all the different measurements, you just contain an index. So the manifest will just say, all right, if you want this particular piece of evidence, go to index 7, and that'll contain the measurement. So we wanted to give a shortcut so that you didn't have to completely reinvent the wheel on an existing SPDM implementation. The big idea, though, is whichever route you take, it needs to give you enough information so that you can compare the evidence and the reference to each other. It needs to be something that a machine can comprehend and compare successfully. So, conclusions. Challenges that came from implementing DICE. This was also heavily referenced in the NVIDIA talk. What do you do if your FMC changes? That's a huge problem, a huge conundrum for all the different device vendors. One of the recommendations in here, and this is actually a recommendation in the binding spec, is we recommend you implement set certificate because certificates might have to rotate in the field. And again, one of the other routes is just make darn sure that your FMC isn't going to have to change. Mapping them together, as discussed, use the evidence binding spec, and then getting your certificate stat correct. That's something that Eric and I have both spent a long time working on, and that's just, review it over and over and over. As you navigate through this, you will find there are several specs that you end up pulling information from to figure out how to format your certificate. And it just takes a lot of scrutiny, because this is another one of those things, you really don't get a second shot at it. You need to get it right. So, where to go from here? Manifest, right, for those of us who go to the OCP security calls, we've had the topic of figuring out manifest on our backlog for what, 2-3 years now? It's been a while. Given the maturity of the work coming out of TCG, it's probably time to go back and revisit our discussions on manifest and the different specs and figure out where we want to go with it, and probably put something down on paper. Along with that is certificate compliance suite. This is something that would be really handy. I don't think we have anything that's pre-canned and ready to go, so we don't have a GitHub link here, unfortunately, but I think that's something that the industry can collaborate on. Join the call, right? That's been up on a lot of people's slides. Something we found extremely helpful is pulling on the libSPDM project. We just wanted to get a mention of that in here for anyone who's not familiar with it. This is an open source reference implementation that comes out of DMTF. It has a number of companies participating in the construction of it, and they actually just announced a new release about 2.5 hours ago. So this is very, very active. This tries to track the latest version of the SPDM spec, so it's a very handy place to go to make sure you are compatible with everything. And then last, the DICE working group. There are a number of specs available. There are more in the pipeline. The SPDM binding spec is one of those that's in the pipeline. That is moving through final approval now. It's actually running in parallel with the DPE spec that's been getting mentioned so much. So that is it. So we've got a little time for questions.
Hello, great talk. I apologize if you went over this and it went over my head. How trivial or straightforward or not is it to craft like a policy, a manifest, which describes measurements which show up some measurements will be in a DICE chain, some will be in an SPDM measurement block. Like, there are different flavors, right? Is the manifest format very well suited to represent both?
It is. Yeah, that's a good question. We didn't get into it a lot in here, but yeah, there are OIDs in the certificate chain that identify the different entries that are added for DICE. And so you can match what you'll end up doing is you'll pull the certificates as well as the evidence manifest, and you have to pull from both of those to compare to the reference. But they will have a consistent mapping of voids between them.
I see. So your DICE when your device mints DICE certificates for the firmware, we'll need to include those OIDs to be compatible with the.
Yep. And for things like, say your bootloader layer, right, your layer 1 or whatever, you're likely going to get that measurement from a certificate. That's probably not going to be in the evidence manifest.
Gotcha. Thanks.
There's also some types in there, so you can describe not only stuff that's immutable, but changes, like stuff for like MVM parameters, things that will change based upon how things are configured. In the evidence manifest, you can say this is basically changeable, so you can describe all those types of things in the manifest.
So let me make sure I grokked it correctly.
Yep.
The manifest, do you expect that to be like offline, handled elsewhere, or on the device?
Which manifest? The evidence?
Yeah.
That can, you can, it has to come from the device. You can either generate it fully on the device or just do a template system.
But what about the journey? Devices, impactless update, config changes, going from debug unsecure, debug secure, any configuration on the devices that are going to change. Like, attestation is not just about firmware measurements, it's also about configuration and the security posture of the device. How do you handle that in a manifest? Does the device have to have memory of its journey as it goes from version A and then gets hot patched to version B and then goes to version C compared to a device that goes A to C?
Patching is definitely a very interesting piece, and I do not think that that's been well thought through in these things.
Probably not.
Right, and we've looked at it in some of our products because it's the question you're asking is a good one. I have firmware at A, and I have firmware at B, and those have two different measurements. And I can rebuild one and install one, but if I take A, patch it to B, likely will not have the same measurements. In fact, it's also probably a good idea if it doesn't have the same measurements. Yeah. So how do you actually encode that? I do not think they've thought that path through, at least not from what I've seen.
The same applies to configuration changes. Not just going firmware AB, but what configuration states have you transitioned through?
In that context, are you thinking? Can you give an example of a configuration change?
Debug enable.
See, to me, that's a mode. That's the device is in a mode, and if you look at SPDM, you basically would boot in a different mode.
Another one, code integrity enabled.
That one.
So you can flag your current mode. The journey, that's a hard one to catch.
Yeah, journey's hard.
Capture.
Yeah, definitely hard. You'd have to basically create one of the questions that has been discussed in TCG is, if you look at the way that TPMs work with PCRs, there's the log. So effectively what you could do is every time you hash extend the PCR, you get a log entry for that. So you can very easily figure out that path. There's been various, I would say, resistance to that in SPDM for various reasons. It does create some storage problems or some maintenance problems, but I think that's the really a method that you would have to be able to go through to see that.
Yeah. Cool.
Just a quick question. How soon do you expect that TCB info extensions to be, the OIDs to be actually registered and available?
So a lot of the work leveraged existing specs. So most of the specs are out there, like the certificate profile and the DICE layering spec, those are all there. The last couple that are working their way through the system are probably, they should be out this year. So end of year.
Then the next thing.
They're all registered under, underneath TCG's OID family. So if you're a member, you should be able to see them in the internal documentation already.
So are you asking about the OIDs for individual components?
No, for the actual TCB.
Okay, perfect. Then Brett's absolutely correct.
Yep.
Any other?
Thanks for the talk. Just one question. Do you have recommendations on software for doing verification?
So we've extensively used OpenSSL, but the problem is that it's right now a very manual process to go through and pull the correct, that basically ASN.1 from each different spec and put it in. So it's, to be honest with you, I wish I had a better answer, and I wish we had a great solution that we could GitHub. But to be honest with you, at this point, what we've done is a combination of OpenSSL. There's a Perl script that'll dump ASN.1, and we've done a lot of manual verification of it.
Parsing all these manifests.
Yes.
Right. So
Yeah,
particularly the stuff that's immutable is very concerning. You as well. So it's definitely, it's not I'll call it user-friendly process. And I think that's something that, Brett and I we're going to try to see if we can get some momentum around doing a project like this through one of the groups. It would be excellent.
Yeah, because I think we're all doing very similar work in silos, and that's not good.
Right. Anything else? Cool. Well,
Thanks, everyone.
thank you.